All right, today's lecture, we're just looking at an extension of what we've been doing already with contingency tables and Venn diagrams, and then conditional probability and independence. So just going a little bit more in depth. So example 1, we have 100 entrants in the local dog show. 25 have all black fur. 8 are Labradors. Additionally, 3 of the Labradors have all black fur. If one dog is chosen at random, find each probability. So here I've given you the bones of a Venn diagram. We just have to fill it out. So B is that we pick a dog that has black fur. L, the dog is a Labrador. So usually somewhere near the bottom, I list our grand total. So we have 100 total dogs in this local dog show. Then I look for the overlap. So here 3 of the labs have all black fur. So 3 dogs with black fur that are also labs. That's our overlap. We're also told that 25 have all black fur. So this entire circle needs to add up to 25. So 25 minus 3 must be 22. So I have 22 dogs that have black fur that are not labs. Okay, 8 of the entrants are labs. So this entire circle needs to add up to 8. So I need to take out the 3 that have black fur. 8 minus 3 leaves me with 5. So 5 labs that do not have black fur. So then what's left over? If I take 100 and subtract 22, 3, and 5, I have 70 dogs that are neither of these two things. They do not have black fur. They are not labs. So then going to the right, I'm answering these questions. So what is the probability that we get a dog with black fur? So we have 25 total dogs that have black fur out of 100 dogs. So 1 in 4. What is the probability that we pick a lab? So it could be any lab. Total is 8. 8 out of 100 reduces down to 2 out of 25. Okay, for C, we're saying we're looking at the complement of the dog having black fur. So the dog does not have black fur. So I'm looking at my dogs with black fur. It can't be anything in this circle. Right, let me try to block it out with 2 hands. There we go. Can't be anything there. So it's anything else. So I can see that there's 75 that are not black fur out of 100, which reduces to 3/4. The other way that I could do that is 1 minus the dog has black fur, 25 out of 100. It gets me to the same conclusion. So either way is fine. Okay, for D, here I'm saying black and lab. So it's saying look for that intersection, look for the overlap between them. That's the 3 right here. So 3 out of 100. We have 3 dogs that are black labs. Okay, here we're saying, ooh, intersection again, but it's not black. So I can kind of block out anything that is black. Also not a lab, so I can block that out too. So what's left over? It's got to be the 70 that's any other type of dog, right? It's neither of the two things. So here I'm saying 70. Let me just white out my extra 0. So 70 out of 100 reduces down to 7 out of 10. All right. Now I see a U for union. We're saying it could be either or, right? U means it could be one thing or both things. So here, if I'm looking at it from a Venn diagram, black fur or lab, right? It could be anything that's in these 3 regions. So from my Venn diagram, I could just add across. I could say 22 plus 3 plus 5 adds up to 30 out of 100. becomes 3 out of 10. But I'm going to keep reminding you, let me do it over here, that if we do it with the formula, I could look at my dogs with black fur, so 25 out of 100. Add that to my 8 labs. And then take away those 3 black labs that are double counted. These 3 black labs are counted here with my black dogs, right? Black fur. And they're counted in here with all of the labs. So we don't want to count them twice. So if I'm using the structure of my formula, I'm going to get the same conclusion. It's going to be 3 out of 10 as well. Just another way of getting there, but either way is fine. Okay, lastly here, this notation means that we're looking at a dog with black fur, given that we've already selected a lab. So this reads as black given lab. So we're picking a black fur dog from our pool of labs. So in our structure, this would mean we're looking at black and lab from among our labs. So we're looking at the overlap. We're looking at the 3. Out of our total labs, the total 8. So 3 and 8 chance of picking a black dog from among our labs. Okay, on to the next. More dogs. So here we still have 100 entrants in the local dog show. 18 have all white fur. 6 of the entrants are poodles. In this case, I'm giving you the or. So here I'm saying that 21 dogs are poodles or have all white fur. I'm not giving you the intersection this time. If you select a dog at random, what is the probability of selecting a poodle with all white fur? So in this case, I'm giving you the union, the or, and I want you to solve for the intersection, the and, a poodle and white fur. Okay, so if you like structure, you could use the formula. I'm going to show you 2 ways to do it. So the probability of getting a poodle or dog with white fur would be the probability of getting a poodle plus probability of getting a dog with white fur minus the probability of getting a poodle and dog with white fur, right? That's the overlap that we're solving for. We are given the union, the intersection here, right? That is 21 out of 100 equal to our poodles, 6 out of 100. Okay, and then here I'm looking at white fur. So white fur is 18 out of 100. And then I'm subtracting my x, my unknown. That's what I'm solving for. So now here I can see that that's going to be 21 out of 100 is equal to 24 out of 100. Okay, and then minus x. So I'm guessing you can see at this stage that really it's got to be 3 out of 100 that we're missing. So x equals 3 out of 100. Right? 24 over 100 minus 3 over 100 would get us 21 over 100. So that's our missing probability. Now the other way that we could do it is we could visualize it as a Venn diagram. Okay, so here are my white dogs, here are my poodles. And we know that we have 100 total. And we know that here the white dogs, we have 18, 6 are poodles, 21 is the or. So let's say that these circles, for example, let's say that it was mutually exclusive. No overlap, like this. let me put the white fur dogs here, my 18, and my poodles here, my 6. So if it was exclusive, mutually exclusive, no overlap, my OR would have been 24, right? 18 plus 6 is 24, but it's not. It's 21, right? It's 21. So if I'm thinking, well, what would the overlap have to be? Well, take that 18, add 6, take away 21. So here I'm adding up my white dogs, my poodles, and I'm subtracting the union, the 21, and it leaves me with 3. So my intersection, my overlap, must have been 3, which means that I would have 15 dogs that are just white, not poodles. I'd have 3 that are poodles, but not white. And there must be 79 other dogs that are neither of these two things. So this is just a way to visualize it and see again, we're getting to 3 out of the 100 total. Both of these options work. It just depends. Do you like the structure of a formula, or do you like the visualization of the Venn diagram? All right, next up. So here we have a survey from 2015 that suggests that 52% of US teenagers use Instagram, 33% use Twitter or X, 20% use both social media platforms. If we pick one teenager at random, let's find each probability. So here uses Instagram, here uses Twitter, or I know we call it X now. So here I'm going to answer some questions, but let's fill in the Venn diagram first. So uses both right here, that 20% goes right smack in the middle. That's my intersection. That's my overlap. Okay, 52% use Instagram, so this entire circle has to add to 52. So 52 minus 20 gets me 32 right here. These guys only use Instagram. Okay, Twitter, here's my 33% total, so subtract that 20. 13% only use Twitter, and then everyone else, I take my 100%, subtract 32, 20, and 13. We have 35% of teenagers who don't use either of these platforms. So now we answer our questions. So A, we're saying doesn't use either. How great. We just solved for that. 35%. Okay, next we're saying uses exactly one. So exactly one would be this 32% that only use Instagram. So this part, right, this little crescent moon right here. And then also the 13 here that only use Twitter. And when I add those together, that makes 45%. Okay, then I'm saying a teenager uses at least one, right? That means one or more. That's really the union that we've been solving for. At least one means it could be Instagram or Twitter. So here, if I look at exactly one thing would be here, here. Two things would be right here. I just add them all up. So I take my 32, add the 20, add the 13, and that gets me 65%. Okay, lastly, going back to that conditional probability notation, here we're saying Instagram given Twitter. So I given T, if I'm just writing that shorthand. So I'm looking at both things, Instagram and Twitter, out of those who use Twitter. So here I'm looking at, right, the overlap, the 20, divided by all of those who use Twitter. So that would be the 33%. Okay, that's what it looks like as a decimal. If I type that in, make it a percentage, I'd say 60.61%. So decimals I like to 4 spots, but percents I like to 2. Okay, one more and then we'll flip. So here, a Twitter given Instagram. So T given I. So that's saying Twitter and Instagram from among those who use Instagram. So both, my overlap is still 20, my numerator is the same, but now I'm picking from those who use Instagram. So my denominator is 52. And I'll do the same thing. I'll write it as a percentage. Usually if I give it to you as a percentage, I like to take it as a percentage. So when I type that in, that's going to get me 38.46%. All right, let's flip the page. Let's look at the back. All right, so here I wanted to circle back to this new variation of Venn diagram where we're looking at the intersections and the unions of three things. So here we're looking at a Venn diagram that shows students in a 5th grade class who study music, French, and art after school. If one student is selected at random, calculate each probability and shade the appropriate region of the Venn diagram. So what's important to note in all of these, if I add up all of these numbers and all of these parts of the Venn diagram, there are 21 total students. Let me tuck that detail at the top. Okay, so 21 total students. M, right, the student studies music, F is French, A is art. So I'm just paying attention to my notation, and I'm going to use my pretty colors to shade in my solution region. So here we're saying this is not music, right? Student does not study music, complement of music. So if I look at where music is right here, it's really saying it could be anything else, right? So anything else in this space that is not within music. So let me quickly shade in my solution region, make it look pretty. And I think that's good enough. All right, so not music, anything else. I could add up the everything else, that's fine, divide it by 21, or I could do 1 minus likes music, so or studies music. So if I add the 2, the 3, the 1, the 1, right, that's 7 out of 21. So I'm going through the complement. That gets me 14 out of 21, which of course I can do math frac, reduce it down to 2/3. So a 2/3 chance the student does not study music. Okay, this one is saying right here, does study music. Where does that intersect with does not study art and does study French? So I probably look at first, where is my overlap between music and French, right? So here's music and French, but does not study art. So this one is out, right? So I'm looking at the region again where they do study music and French, but not art. So right there, that's singular, one person. So 1 out of 21. Okay, and then lastly, the union, right? We're saying if it's a union of things, it could be someone who studies music, could study art, could study French, could study one of these things, could study 2 of these things, could study 3 of these things. So the union, we're saying it could be either or, could be 1, 2, or 3 of these things. It could be anything that falls in these circular regions here. Okay, so again, I could add up all of those individual parts, or I could go through the complement. Probably faster if I do 1 minus 4 out of 21, and that gets me 17 out of 21. All right, next skill, we're going to actually build one of these Venn diagrams. So let me slide this up to here. Okay, so here we're talking about newspapers. So a survey was taken to find out what newspapers people read. The results of 200 respondents are below. Let me just add that detail here. So 200 total respondents, participants of our survey. Okay. We're supposed to make a Venn diagram to display the sample space. And if one respondent is selected at random, calculate each probability. Okay. So 12 read A, B, and C. So that 12 that do all three things go here. Okay, we have 26 that read A and B. So this part here has to sum to 26. So this must mean 14 only read A and B. Okay, not C. But all of these guys here, all 26, they actually read A and B, right, in total. These guys here just also read C. This 14, only A and B. All right, 39 total read A and C. So total read A and C. So 39 minus this 12 gets me 27. These are the individuals that only read A and C. Okay, 27 read B and C. So right in here, this has to make 27 total. So take away 12, here's 15. 70 total read A. So this entire circle is A. So I take 70, subtract 14, 12, and 27. That means that I have 17 who only read A. 69 total read B. So this circle has to add to 69. So take out 14, 12, and 15. There are 28 who only read B. And then 84 total read C. So again, this adds up to 84 total. Subtract the 27, 12, and 15. Here's 30 that only read C. Now there's got to be people who don't read any of these newspapers. So if I take my 200 and I subtract the 17, 14, 28, 27, 12, 15, and 30, I'm left with the everyone else, right? This 57, they don't read any of these newspapers, not A, B, or C. All right, so now we answer the questions. So what is the probability we pick someone who only reads C? So only C, no other papers. So I'm looking at the 30 right here. So 30 out of 200. So 3 out of 20. So again, C only, right? No other papers. Okay. For B, exactly 2 papers. Exactly 2. Okay. So let's look at those regions. This 14 right here only read A and B. Exactly 2. This 15 only read B and C. So again, exactly 2. This 27 read A and C. So again, exactly 2. So I'm adding that 14, 15, and 27 gets me to 56. I take 56, divide it by 200, reduce it down, and I get 7 out of 25. Okay. Next up, less than 2 papers. So reads less than 2 papers. So less than 2 papers means, right, could be 0 or 1. So 0 or 1. So 0 papers would be the 57. Exactly 1 would be 17, 28, 30. So I'm going to take the 57, add it to the 17, 28, 30. Adds up to 132. Okay, divide that by 200, reduce it down, we get 33 out of 50. Okay, lastly, at least 2. So at least 2, at the very least 2. So it could be 2 or 3. So here's exactly 2, and then here's all 3. So I'm just adding those up. So 14 plus 15 plus 27 plus 12 equals 68. Right? I can divide that then by the 200, reduce it down, and I get 17 over 50. Now, of course, I could also just go through the complement since I just solved for it over here, the complement. So my other way to do that would be to do 1 minus the probability of 0 or 1, right? Again, I just solved for that. So 1 minus 33 over 50 just confirms what I just solved for, 17 over 50. All right, next one. Last one. Is there a relationship between gender and allergies? A random sample of 88 U.S. 11th and 12th graders was selected. A contingency table, so a two-way table, summarizes the gender of the students and their response to the question, do you have allergies? Suppose we choose one of the students in the sample at random, find each probability. So if we're going to say that these two scenarios are independent, gender and allergies, then we need to show that the probability of picking someone with allergies is the same if we're picking among females and among males. So first, if we look at the probability of picking someone who has allergies, so allergies, yes, here I'm looking at what that total is, 34 out of my total respondents, which is 88. So looking at the 34 over 88 gets me 17 over 44. Okay, as a decimal, it's going to be easier to compare them as decimals. So I'd say that's about 38.64%. All right, so among everyone participating, we're seeing that about 38.64% have allergies. So how about among females? This reads as allergy given female. So we're looking at allergy and female from among our female participants. So here, allergies and females, we're looking at 19 out of our total females, 43. So 19 out of 43 would be the fraction. As a decimal, we'd say 44.19%. And again, that just makes it easier for us to compare them. Okay, and then how about allergies among the males? So we're looking at allergy given male. Allergy and male from among the males. So here's my allergies and male from among the total males. So I'm looking at 15 out of 45, right? That's 1/3. So as a decimal, 33.33%. Okay, so now the question becomes, are gender and allergies independent, right? Or is there a relationship between the two? So here we'd say not independent, right? It's not independent because there appears to be an association, a relationship between these two things. So I'm going to say there is an association. The breakdown is too different. We're seeing that there's really a greater proportion of allergies among the females compared to the males. So I'll write that as my summary statement. So allergies, more prevalent or greater percent among females than males. Okay, so independent, if they were independent, we'd see a similar breakdown of our general group having allergies as those among our two subgroups here, as among the females and among the males. We did not see that, so we said not independent And if we're saying not independent, then we're saying there does appear to be a relationship. There is an association. Allergies seem to be more prevalent, a greater percentage among females than males. Lastly, are events male and allergies mutually exclusive? So we're saying if they are mutually exclusive, there should be no overlap between them, but there is, right? We have males with allergies right there. So we're going to have to say no. Males have allergies. Right? There were 15 in our group right there. So males have allergies. There is overlap between these two events. So not mutually exclusive. All right, that's all I have for today. Have a good rest of your day.